Okay, we should be live. Welcome to Advent of Code Day 14. Yesterday was a bit of a nightmare because I took so long parsing out the code, and I kept going back to thinking, well, I need to just write a character parser and do it, because I know you can do a JSON parse and just eval like the code and have it, but that's not really. I ruled that out right away. But yeah, was that smart? I don't know, but I like to code stuff myself. So I was trying to do the chapters for yesterday. These are the YouTube chapters for yesterday's video. I haven't completed yet. I need to still watch a bit more and add the final bits of the chapter. But yeah, it will give you an idea of how my day went yesterday. So yeah, let's hope today will be a better day. I got myself a nice big cappuccino. Let's hope it's still nice and drinkable after I complete, because that's also usually the issue. By the time that I'm done, I have not drank my cappuccino and it's cold. So let's see if today fares a bit better. But as the days go on, challenges get harder, so yeah, let's see how it goes. Let me put this day in the chat as well and pin it, just so that you can easily follow along if you have no idea what I'm doing. Oh yeah, I can also still review yesterday's code for a bit if you want. I refactored it after everything was done. I refactored it a bit and still not done. Because usually I like to post like my code and some comments to Reddit, just so that more people can see the stuff that I make. I have not done that yet. So for day 13, yesterday, I ended up with this code, and basically I've refactored everything into a is_smaller function, which is basically a compare function that returns -1, 0, or 1. And if it's -1, pair A is smaller than pair B, so then we add it to the valid pairs. Just about the same for part 2. It inserts the extra packets and then it just... do I actually still run the code here? Let me see. That's a good point. Ah, yeah, here it's sorted. My bad. And then it extracts out the extra packets. Yeah, it's still early for me, still getting started. So yeah, as you can see, the code is now a lot smaller than before. The wrap function that had a bug, what I've changed here is I extracted it out because I had it twice in the code, and I actually, since we just move forwards, never backwards, I removed the part that would add the previous part of the string. So if we get here, we have already processed everything before. So what you can see is if this one gets executed and returns true, it overrides A and it resets the index, and then it gets a new reference for the current character it's looking at. If we get to this unequal state, so this is basically the sort function here, and these values are no longer used. As you can see, I have not finished refactoring yet, but basically what it does is it first checks if either one of them is a list, since we compare or check that multiple times and put that into a bool as well. So if A is the list, but B isn't the same as A, so basically this can either be true or false. If there's any inequality here, so A is the list but B isn't the list, or A isn't the list and B is the list, then we do this stuff. NFT Jazz. Hi Nick, good morning. Thanks for stopping by and checking out my Advent of Code. I was just going over the code that I ended up with after yesterday, which was a bit of a challenge. So I also removed a lot of checks here, because basically if we get to the unequal state, if it can find a digit that it can wrap, that's fine. If it can't, that means that and I've left code here, that B has a deeper nesting. So I have also added more early exit conditions, removed a lot of duplicate checks, So yeah, the code is now a lot smaller. So also this, basically it's compare one to the other. So I use the compare to of int32, which also returns -1, 0 or 1. So yeah, this can also be removed. This guy is the next argument. Oh no. You should watch yesterday's stream and see me struggle for 3 hours. Try to figure out how to write the parser. So I'm no genius. I just love coding, and yeah, I've been having fun doing writing software for over 20 years. So it's just a passion of mine. I'm in no way, shape or form the best coder out there, but usually when I set my mind to something, I can get just about anything done. So, but that doesn't mean that I'm the best coder out there. So thanks for the praise, but I don't deserve it. Let's see. This is set up for today's challenge, so let me put that here as well. And let's actually check out what we need to do. Let me take another sip of my cappuccino. It's nearly 9 in the morning here, so yeah, it's a great breakfast drink. Let's see. Regolith Reservoir. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Correction, the distress signal leads you behind the giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could actually become trapped. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. You scan a two-dimensional vertical slice of the cave above you, your puzzle input, and discover that it's mostly air with structures made of rock. Your scan traces the path of each solid rock structure and reports the XY coordinates that form the shape of the path. The X represents distance to the right and the Y represents distance down. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight, horizontal or vertical line to be drawn from the previous point. For example, let's see. This scan means that there are two paths of rock. The first path consists of two straight lines. The second path consists of 3 straight lines. Specifically, the first path consists of a line of rock from 498,4 through 498,6. Okay, so that is basically 3 spots, 4, 5, 6. And another line of rock forming from there. Okay, that is in the other direction, so this is horizontal. The sand pouring into the cave from point 500,0. Okay. Drawing the rock as a hash and air as a dot and the source of sand as a plus, this becomes, okay. Ah, it's actually, okay. I wonder, yeah, it also goes backwards. So you have to be careful. If you like write this as a loop, you have to let's see. So basically what we need to do is find the common number and then find lowest to highest for the other one. So that will be something that we need to write. So when you compare these two, it's always like horizontal or vertical movement. So you need to find which of the axes match up. Take that as a constant, then draw a horizontal or vertical line, take in 2 values and then order them to be smallest to furthest away, so that you can always write the same kind of loops to draw them. So yeah, that is good to know. So you have a start point and then moves. So basically the amount of lines that it generates is always the amount of coordinates minus 1. So this is true, so it will make 2 lines. This is 4, so it made 3 lines. So you have 1, 2 and 1, 2, 3. Okay, let's see. The scan means there are two parts of rock. The first part, yeah, we did that. Sand is pouring, yeah, okay. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill 1 tile of air in your scan. A unit of sand always falls down 1 step if possible. If the tile immediately below it is blocked by rock or sand, the unit of sand attempts to instead move diagonally. Okay. 1 step down and to the left. Okay, so it will... Okay. If that tile is blocked, the unit of sand attempts instead to move diagonally 1 step down to the right. Sand keeps moving as long as it's able to do so. At each step, trying to move down, then move left, then down left, then down right. Okay, so sure. If all 3 possible destinations are blocked, the unit of sand comes to rest and no longer moves. At which point the next unit of sand is created back at the source. Okay, so it's all individually. So drawing sand as it comes to rest at O, the first unit of sand simply falls straight down. Okay. Okay, so just to give you my reasoning, looking at this, when you have small sections of data in a very large space, you usually want to make a sparse map. That means you don't make a big XY grid where you mark every place. No, you just mark the spots that are interesting. So in this case, you will only keep track of these indices in a hash set, and you won't bother recording everything that's space. So what I want to do is just write something that can generate these lines, then build those XY values into a hash set, and then we do this logic where you look at the current position of where it starts, you check the down position, and until there is a blockage, you do that. Once it stops, and then you do the diagonal parts, but you also just check based on their possible indexes. So let's see. So what I am wondering is if it does the diagonal move and then is able to fall down again, I think that is what it will do, right? So if it goes diagonally, if the space below it is free, it will go down again until it's rested. Yes, a unit of sand always falls down 1 step if possible. So basically this logic of going down, then down left, then down right, once you be able to do one of those, you start back at going down and attempting then back left again and then right. And only if you come to an end where none of those worked, then you can move on to the next one. Okay. Oh, let me read a bit more here. Yes. Then the second. Oh yeah, you can see that here right now. Let's see. So if it goes here, then it goes all the way down, and then it rests here. Yeah, you can see that here. So it would go downwards here, and then drop here. Boom. Finally, 2 more units of sand can possibly come to rest. All further sand flows out the bottom, falling into the endless void. Ah, okay. So this is also interesting because what we need to do to calculate this is actually yeah. What we need to do is keep track of the lowest y coordinate, because that is our deepest floor. And once we have a piece of sand that goes below that floor, then we know that the entire path back up is invalid. So that is an interesting one to know. So we probably should keep all the sand that we track down into a separate new list that we check. And only after it's come to rest, then we add the whole tree. Because like the situation here, when we get to this state, we have a dead end. And basically that means that we don't add this last tree all the way up and just report complete. Let's see, how many sands of unit come to rest before the sands start flowing into the abyss below? Okay, so that's a nice additional challenge that they stuffed into the part 1 already. I like that. This is this actually, it's nice, it's a challenge. So this is all just logic based and I like it. Let's do some coding. Let's also just take a few example inputs. And actually I should probably just actually take the example input because it's hard enough as is, and we'll just take this. So I overwrite my input and I'll do it like this. And then I say, how do we call it? It's not it's a polygon, right? Well, not a polygon because it's not closed. It's a multi-path line thing. So we just do var lines is input, that's 2 lines. And then we do select x dot split by, and then we do this. Const string point bar this. We split by the point separator. We select on those. X dot split on comma. And then we do as. And let me just wrap this so that you can follow along what's actually happening. So we do as, and then we do int the parse x, and we do the same twice. So what this now makes is a list of xy pairs. And I need to do this as well. So now we can do the signature for this becomes a list of int x, int y. So now we have our input mapped so that we have all these pairs here. And let's make this available to the rest of the program. Like that. So we do hash set int y. Let's just keep xy in this case because that's the way the instructions are. Usually when I go to a non-sparse map I use yx because the first level will always be rows and then columns. But yeah, in normal notation I like to write it as xy, as most people. Map is blah blah. Then we need to have a bool horizontal int from int2. parse. Yeah, basically parse, and then we have a b, which basically just returns a.x equals a.y equals b.y. That means that the vertical position is fixed and we move horizontally. And then we do we need to know this to know which axis we need. So let's do bool horizontal is a.y equals b.y, and then we do yes, return horizontal, and then we do if horizontal, we do a.x smaller than b.x, a.x, b.x. So let me wrap this in a case so that it's more readable. Otherwise it's vertical, and we do the same for the y coordinates. So then we do a.y smaller than b.y, we do a.y, otherwise b.y. Doesn't it like that? Oh yeah, and then we have the inverse of this. Okay, let's do int from int2. It's better to just do it like this. If horizontal, because it becomes so illegible after. We do from is and I still should do it like this. If this from is a.x, 2 is b.x, else from is b.x, 2 is a.x, and then we do the same for y. We can actually use this nesting here. Because this is a bool, so it's only two states. So if it's bool, it's vertical. So now we can do the y. This all becomes y. And then we do horizontal from to. Like this, right? So this is parsed. Then we can do IEnumerable int x, int y, draw a line, and then we do the same here. We feed it this rule. So we do if horizontal, else, and if horizontal we do for int x is rule.from, no, not build, rule.from. Rather than how you normally write your for loops, we need to have it inclusive, because the 2 is inclusive in this case, rule.to, and we increment x, and since we have ordered it from lower to higher, we can always write the for loop like this, so that makes it easier, and we can do yield return int fixed axis value. Let's do it like that. and then we do x comma like this, and in the other one we do and we should probably just add this to the rule, by the way. Just to make it easier. Then we have it all unpacked. Do fix axis is actually, we can do that here. Is a.y. And since I took a shortcut here, I can just do it twice. It doesn't matter. I was like, I can initialize it to x and then do it there, but yeah, it's a fixed axis value. Okay, so now the signature is fixed. This becomes rule dot like that. I really need to make a cough button. Me scrambling in OBS to mute the mic. Is everybody still following along what I'm doing? Does it make any sense to you? Okay, so this one lets us build the lines that we need. So now we can do for int I is 1. First we do for each var rule int rules lines actually. Let's call it a line then. Then we do for int I is 1, I smaller than line dot count. And this is basically because we have to have a start point to refer to, so I'll just start at 1, move to the end, and just take the previous value as my A point. So let's say we have we do it like this, and we do rule is parse, and this means we do line I, and we compare line I minus 1 to that. Like this, and then we do for each var point in var line rule, and then we do map.add point. Let me draw out the map just so that we have something like that. So we can do void draw map. This is our map signature. If min x is map.min x. Since it's a sparse map, we need to know what our ranges are. So this becomes y, this becomes y, and these become max. So we do for int x is min x, x smaller equal max x, increment x. Do the same for y. Let's do the rows. We need to do this by row because we are drawing to the console, not to a bitmap. Let's see why. Okay. Console the right line. Then we do if map x comma y contains actually. And then we need our dark characters like I had before. Which day was that? that day 10? Yeah. I should probably put that in the extension, but yeah. Let me reuse it here again. I should probably have another one for sand, but I'll just do the print map for now. So now we can do console.write, not right line but right, and then we do filled empty. Okay, so after we build the map, we can draw the map, and let's see what that looks like. Okay, that looks similar to what we have in our, let's see, that looks similar to what we got here, right? Can you tell? So that works. And now they say the sand is pouring in from 500,0. Okay. Let's code that as well. Sand drop from this. Okay. Basically, this is for part 1, so I can just put it here. Okay. So now we need to Good morning, Anders. It's going a lot better than today already, so written some stuff that's already useful and works right away. And now we need to do the sand falling thing. So let me just see how we can do that, because it's like it needs to go down. Yeah, basically it needs the map and then the logic to fall down. So let's see, bool rested. Better for you, less entertainment for me. Well, you can always go back and watch yesterday's stream again if you want. And me frustrating. I need to do work anyways. Yeah. Let's see. Rested. Int x, int y, and position. Drop sand, and this will be map, and this will be int x and y from. Okay. So now we do int max y. So this is important to know. As I said before, we have the sand falling down. In this case, where is the infinite example here? So what we need to do is get our biggest y value that we have. If sand will go down below that value, we know that we have an issue, right? So now we do int lowest floor y is map.max x y. So this is our constraint. If it goes below that, we know that we're in an infinite state. Oh, it's actually, yeah, since it's a single thing going down, it doesn't matter. We can just, yes, it's easier than I thought before. So let's see. Bool rested is false. Okay, let's see. Because there are 3 moves that we need to do, and bool moved is false. Let's say we start at true, and we do while moved, and we need to have int x, int y, xy. X is from dot x, y is from dot y, and y smaller than max y. Okay, here we go. So now we can do if map contains let's also do int x, int y, next pos. So we do next pos is x comma y plus 1. Actually, we probably don't need this anyways. We do is from. Actually, we can just use the from. Never mind. From dot y. So oh, we do need it because we need to alter it based on where we are. So we do int x, int y. Next pos is from. Okay. If next pos is next pos is from dot x from dot y. If next pos if map contains next pos, okay, try down left. Next pos is from dot x minus 1 from dot from dot y minus 1. Try down right. Let's see. So this one becomes positive x. Also this is plus x, not minus x. Plus y, not minus y. So let's see. Move is false. So then it ends at the from, and else, let's see, if moved from is next pos, like this. I think this is the way that we do it, and then we return here, return moved from, actually. I think this is the one. Let me see. So let me do bool no, it's actually a do. It's a do loop. And then we do drop is drop sand, and then we do sand drop from. And we do while dropped. We need actually to put in the map. And then we have lowest for y. Okay, while dropped dot, and we need to put this outside of our loop so that we can refer to it. So while dropped dot rested, we do that. Boom, 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 boom. Let's fake it here, and we do yeah, we can do it here actually. So we do if drop, okay, it doesn't matter. This just makes it less clear. So we do while true actually. If drop but rested, else break, and we break out of the loop. We do map.add, let's see, we do drop.end position. And let's also make a clone of the map, just so that we can refer to what is sand and what isn't sand, because we can't track that right now. I could build it into a dictionary instead of a hash set, but I don't know if it's needed. Let's see. What is actually the question that is asked? How many units of sand come to rest before the standard flow? Okay, so basically what we need to do is take a count of the number of entries here. So we do int floor count is count. Then we do int sand count is map.count minus floor count. Right line. Sand, and this becomes a sand count. So let me draw the map before and after, and let's see if this works. Okay, the 0 sand, so that's not good. Okay, let's step through it and see what happens. Set next statement F11. Basically I need to return actually this one, so my moves logic is wrong. Let's see what it spits out now. Woohoo, 24. Let's see, is that correct? 24, okay. So let's try the real input. So we remove our fake input here and let's do this. Ooh, that's a big one. 737, like a Boeing. Woohoo! That was easy enough. Well, it's 40 minutes into the stream, but still it felt flowing nicely and working correctly without any major issues. So let's continue to part 2 and let me drink some of my now getting cold cappuccino. Let's see. You realize you've misread the scan. There isn't an endless void at the bottom of the scan. There's a floor and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with the y coordinate equal to 2 plus the highest y. Okay. Sure, I have stuff for that. In the example above, the highest y coordinate of any point is 9, so the floor is at 11. This is if your scan contained one extra rock path, like infinity, 11, infinity, yes. The example above now looks like this. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to a rest at 500,0. Okay. Blocking the source entirely and stopping the flow of sand into the cave. In the example above, the situation finally looks like this after 93 units of sand come to rest. Okay. Okay. So now I need to do this differently. Let's see. I have this one, the drop sand, becomes drop sand 2. This is still okay, but it's actually returned from dot y larger than 0, because basically if it's at 0, it's an issue, and that might be the last one that we need to do, but let me just check that. This y, we need to do that differently as well. Because we don't need to stop there. What we need to do that is so we do if next pulse dot y is max y, or let me see. Yeah, because basically if this is the y, that position exists. So this is fine. But also okay. Yeah, it will just stop there. That is correct. Okay. Let me see. I think this is it actually, and I just might have it off by 1 because I now return if it's bigger than 0, so the last one might not trigger. Actually, I can start from -1, and that would make it better. Yes, let me just copy this to part 2 and see if my idea is correct. So I would start from -1, and then if it's larger or equal, then it will be good. Draw line 2. I mean drop sand 2, like this. And let's go back to the test input. Oh yeah, and I also need to increment my max by 2. So it's this plus 2. So let's see what happens now. And I get an infinite loop or something. Let's see, next bus. I need to do else move is false. Good. 115. Is that correct? Oh. Let's see where my program has a bug, because it has that one correct and that one correct. Because it starts at -1. Okay, let me just start at 0 to make sure that it's correct. Yeah, that's what you get when you try to be clever. Boom, 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 boom. And that's why it's good to run the test case, just in case. 92, and then we have the off by 1 because we don't have the top 1. So it should always be, yeah. Actually, what I can do is just, after it's done, map.add start drop from, send drop from. Like this. And this gives you the right answer. Okay. So let's run the real input now. And I probably shouldn't draw this. Okay, that's a big one. Woohoo! Day 14 completed. Oh, that feels good. It just feels good to have a smooth day. And I know I'm not the fastest guy to solve this, but it felt like smooth, steadily chugging along, getting things done. Yeah, that's the way I like it. So. That was nice. Okay, so I think that's it. I think I scared most of the people watching me with yesterday's thing. In a bigger window. Okay, I can do that. Let me do console read line. Just pop back audio and saw you in. Nice, good timing. Let's do that here. So yeah, okay, let's make it a big screen. There you go. It's still too big. It still overflows the screen, but yeah, it works. Okay, so I probably, let me see if people posted a solution to the Discord. Nope. I really think I've scared off most people that were watching me during the days with yesterday's stream, and they're like, I don't have time for 3 hours plus of debugging. So yeah, no worries though. I've had fun. So thank you, Anders, for keeping me company today. I like that today was ASCII art. Yeah, actually there was a day. Let me see which day that was. OCR. Day 10. So I can show you day 10 if you want. So then I do R, K, A, Z, J, B, and then it does it. So I wrote a, actually it's like a CRT screen, and they outputted pixels, and then you need to like get to know what the pixels are. So I wrote an OCR, small OCR engine to map that out. So yeah, they do more drawing stuff. And actually, if you go to the Reddit for Advent of Code, there's lots of visualizations. It's also early morning in Europe. Most people work or cry about power bills. Yeah, but I've had a few people that would pop in every day and share their code, etc. I really think I've scared them off by yesterday's disaster of a stream. But yeah, no worries. I still had fun, so it's all good.